You know the feeling. We've all been there. You jump in the car, turn the key, and nothing. Just a click, or maybe even worse, just dead silence. It's so frustrating. But you know, a lot of the time, the bad guy is this small, super hardworking part that we never even think about, the starter motor. So today, let's dive in and turn that frustration into some know-how.
So here's the game plan for this explainer. We're going to cover the whole journey. We'll kick things off with understanding what the starter even does, the engine's ignition spark. Then we'll get into safety and tools, because that's always job one. After that, we get our hands dirty with removal and disassembly. Then it's time to play detective and investigate the components, followed by the actual repair and putting it all back together. And of course, we'll wrap it up with the final all-important test. By the end, you'll see the whole picture of how you can bring one of these things back from the dead. Let's get into it.
All right, first up, let's properly meet the star of our show. What exactly is this thing, and why is it so incredibly important?
I mean, it seems so simple, doesn't it? You just twist your wrist or push a button. But behind that one little action, there is a whole chain of events that has to happen perfectly.
Think of the starter as the engine's personal hype man. It's this powerful little electric motor, and its whole job is to jam a gear into the engine's flywheel. That's a huge, heavy, toothed wheel. The starter gives that flywheel the massive first spin it needs to get the whole combustion cycle going. Pistons moving, fuel burning, the whole shebang. Without that initial kick, your engine is just a really, really heavy paperweight.
Okay, before we even dream of touching a single bolt on that car, we have to talk about the most critical step of any repair job, getting prepped and doing it safely. This part is absolutely non-negotiable.
Look, these aren't just suggestions, they are the golden rules. Especially that first one, disconnecting the negative battery terminal. That one simple move de-energizes the whole electrical system. It prevents sparks, it prevents short circuits, and it's just plain smart. Think of this as your pre-flight checklist before you take off.
And of course, every mission needs the right gear. Here's our toolkit. You got your standard stuff, your sockets and spanners, but look at that multimeter. That thing is our diagnostic superpower. It lets us literally see electricity. With it, we can test all the internal bits of the starter and figure out exactly where a wire is broken or shorted out. And yeah, you see cleaning supplies on there? They are way more important than you might think.
All right, with all our prep work done, it's finally time to get our hands dirty. We're officially moving into the extraction phase. Let's get that starter motor out of there. The process here is pretty straightforward. First, safety first. Disconnect that battery. Then, you gotta find the motor, which is usually tucked in right where the engine and the transmission meet. And here's a pro tip for you. Label the wires before you pull them off. A little piece of tape with a number on it will save you a world of pain later. Lastly, just support the weight of it as you take out the last bolt and then gently guide it out. This is a huge warning, and for good reason. Even with the battery disconnected, that big, thick power cable can sometimes hold a residual charge. If that cable touches any metal on the car's frame, you can still get a really nasty spark. So just be mindful and keep it clear of everything. Once we get it onto the workbench, the real fun begins. And listen up, because here's probably the single most important tip of this whole explainer. Right there in step 2, mark the casing before you take it apart. Seriously. A simple scratch with a screwdriver or a line of paint across the different sections creates a roadmap that guarantees everything lines up perfectly when you put it back together. Okay, with all the pieces laid out in front of us, we switch hats. We're not mechanics anymore, we're detectives. Our job now is to inspect every single part and find the clues that tell us why this thing failed.
Our first tool is the good old eyeball test. We're hunting for obvious signs of trouble. Are the brushes, those little carbon blocks that send power to the motor's core, worn down to nothing? Are the teeth on that little pinion gear all chewed up and broken? A lot of the time, this simple visual check is all it takes to crack the case.
Next up, we pull out the multimeter for some hard evidence. This table is basically our cheat sheet. We're checking the electrical pathways for two main things, continuity and shorts. Now, continuity just means there's a nice, clear electrical highway where there's supposed to be one. A short circuit? Well, that means electricity has taken a wrong turn and is going somewhere it shouldn't, causing all sorts of problems.
And this slide right here breaks it down perfectly. Let's look at the armature. That's the spinning heart of the motor. A good one will show a clean electrical path between all those little copper segments. But it will show absolutely no electrical connection to the steel shaft in the middle. A bad one? Well, it either has a break in the path or it's leaking electricity to the shaft, a dead short that just kills the motor's power.
Okay, detective work is officially over. We found our culprit. Now it's time to put on a different hat one more time. We're the surgeons now, and we're going to bring this component back to 100%.
You know, a huge part of this repair process is really just careful, meticulous cleaning. Take the commutator, for instance. That's the copper section where the brushes make contact. Polishing that up with some fine emery paper is so important. A clean, smooth surface means electricity can flow with almost no resistance, which gives you all the power you need for a strong start. But you know, sometimes cleaning just isn't going to cut it. You have to know when to repair and when to replace. Parts like brushes and springs, they're designed to wear out. If they're worn, you just replace them, period. And if your multimeter found a major internal electrical problem in something like the armature, yeah, replacement is really the only way to go. And now for the really satisfying part, putting it all back together. And this is where that little trick from earlier pays off big time. See step 3? All we have to do is line up those little marks we made, and boom, we know everything is in exactly the right spot. Once it's all bolted up, just give it a quick spin by hand to make sure nothing is catching or binding up inside.
So, it's all back in one piece. It looks right, it feels right, but there's one last test it has to pass before it earns its spot back in the car. It is time for the moment of truth.
This is what we call the bench test. We use a battery and some jumper cables to power up the starter safely on the workbench. This is so critical because it tells us if our repair actually worked before we go through all the trouble of reinstalling it. And be safe here, that little motor has so much torque, it'll jump right off the bench if you don't clamp it down tight.
Okay, it's clamped down, the cables are on, we're about to give it the juice.
And that's it. You hear that solid thunk as the gear shoots out, and then that high-pitched whir of the motor spinning like a top. No weird grinding, no hesitation, just smooth, powerful, clean rotation. That right there is the sound of success.
So we went from a frustrating silent turn of the key all the way to a powerful spinning motor. We've demystified this little unsung hero. It kind of makes you wonder, doesn't it? What other simple things that we use every single day are actually hiding this incredible world of complex engineering just